Co-exposure maximization in online social networks. Assume there are two campaigns, respectively red and blue in the social networks, which stands for opposing side of controversial social issues. They want to promote the opinions through viral marketing services, for example, from Facebook and Twitter. We apply the classic stochastic information propagation model, that is, the independent cascade model to build the opinion transmissions. And our goal is to design a seed cell allocation framework from the host side also for the social good list. In traditional viral marketing setting, the goal is to reach out to the maximum number of users of each side. The most influential seed nodes for each side will be picked. When applied to in societal settings, this framework leads to biased campaigning and reinforces the echo chambers. Like this example, little users are exposed to information from both sides. Such phenomena should be mitigated. Our solution is to change the objective function. That is to say, to get more people receiving information from both red and blue. That is co-exposure maximization. We already have the objective function. Next are the constraints. We assume that red has a budget for KR loads and blue for KB loads, and we avoid selecting the same loads for both campaigns. In this way, we avoid confusing the users with conflicted viewpoints. So how to select the seed loads? Our problem coin is NP-hard. We reformulate it into maximize F function subject to a set system constraint. This set system is a P system. F is not submodular, while we find a G function that is submodular, monotoal, and has a multiplicative difference with F. We apply the greedy algorithm on this G function and get an approximation of this F and coin. And this XR and XB are the signals for the red and blue. It's sharply hard to calculate the expectation of the G function. We apply the generalized reverse influence sampling technique. In our paper, we call the special reverse reachable set RRP set, and we make just enough samples such that the FRX will estimate the expectation of this GX, and then we apply the greedy algorithm on this FR function. For technical and experimental details, please refer to our paper and poster. Thank you for your watching.